Hey guys, how's everything going? This is Jason, who is not good at algorithms. In this video, I'm going to take a look at A24 Go Latin. A sentence S is given, composed of words separated by spaces. Each word consists of lowercase and uppercase letters only. We would like to convert the sentence to Go Latin. The rules of Go Latin are as follows. If a word begins with a vowel, and append a vowel means A, E, I, O, or U. Append ma to the end of the word. For example, the word apple becomes applema. If a word begins with a consonant, not a vowel, remove the first letter and append it to the end, and then add ma. Means goat will become oatgma. Add one letter A to the end of each word per its word index in its sentence, starting with 1. For example, the first word gets A added to the end, the second words get AA added to the end, and so on. Return the final sentence represents the conversion from S to Go Latin. As speak Go Latin, it becomes I at ma, speak pixma, goat, oatgma, Latin, anti L M ma, and then update AAA, and the refiner return this. Well, is this an algorithm problem? I don't know. We just loop through the word and process it and return it, right? Yeah, maybe the problem becomes how we can extract the word from the input. S only contains only uppercase, there is spaces only, exact one space between each word. So there will be no irregular cases. So, well, I think I'll create a generator, and then for each word, I'll process it and yeah, effect generator. Yeah. Can I use generator generator function here? Well, I think I could. So let's try it. So we create a generator function called next word. For this function, I'll separate it. Okay. So we get the input like a string. So we start with the index from 0, and what we will traverse through the string. When we met a space, we will return that the word, right? So while I smaller than, so the end will add the while loop will end at the index here. So I smaller than string oh, okay, so str I will go to last letter, so then okay, I will plus 1. And if str I equals to space, it means the previous space, from the previous space to this one, to this space, will generate there will be a word in it, right? So we yield string slice I, previous. Let pre equal 0. Let's I start from 0, and then we found the space. Yes, prev to I, and then do what? We set prev to I, and then go to the next one. Prev to I? Actually, no. It should be plus 1. we got the space, and then go to next one, but we need to set pref, not pref, I need to pref start to I+1. This should be good. And then do what? At last, it will I will end here, right? It's not space, so we need to yield the last one. Yield the last one, which is slice start I+1, right? Or we could make it better. We set it to +1, or I equals to str.length. We could also yield the result, right? So I'm not sure about the generator syntax. Let's for let word. Okay, wait a minute. Console log gen word generator equals next word s for let word of word gen. We log it. We input like while we're pending, I need to log in. Okay, so we have tried the generator. We see I speak Gold Latin. I think we did the right implementation of the generator, the word Latin. So okay, is the index work? I'm really not sure. I think not, right? Word I. Yeah, it's the index does not work. So for each word, I'll create a result. And so for each word, what we will do, we will check if the first one is a vowel or not, right? So if we define a vowels A, E, I, O, U. If vowels, okay, we could use set. If vowels has word, the first letter, let the new transform empty. Okay. If the first one is a vowel, we add ma, right? So transform, we get it to renewal. Set it to word plus ma. If it is not, transform equals to word slice 0 plus word 0. We put it at the end and plus ma, right? And finally, we need to add extra a. Transform plus equals to the length. Okay. The transform plus the first one will be get 1a. So we need to generate a for I equals 1. I smaller than result dot is plus 1 equals to it. So this I plus 1. Transform plus 8, right? And then finally, we could push result in. Or we could just we don't need the result, but yeah, we could push it. Push the transform, and finally return result join empty. Let's try. Looks good. We got uh-oh. Each means a comma, but oh, uppercase does not count. Only small letters, right? Huh? Wait a minute. We put e to the yeah. So to lowercase. Okay, we are accepted, but we are not that fast. I don't know whether we have better solution for this one. Just do as what we follow. There's one trick that I think we could improve is that we don't need this for loop to append the a, right? We could say let the appendix equals default is for must be a, and then we could just add to the end and update the appendix to next one, right? So we could remove the for loop here, and will this be better? Maybe, and maybe we don't need the result array. We could just use result, like string. Rather than push, we just plus. But we actually need to handle. Okay, so if result is empty, then we should add the word transform. If it's not, it should be space plus transform, right? And we return result. Could this be better? Oh, should be like this. Oh shit. Well, let's try to analyze the time and space. We use a generator. This will be linear time for all the letters. And here we check one and just do the slice. Slice actually will cost linear time, right? For words. So totally equal to linear time. And totally, yeah, linear time. Space. We don't use extra space. We use a temporary result, but it's not auxiliary. It's necessary as a result, so it's constant. Let's try to see if someone did better than us. String. Straightforward. Each word. Rotating? Where is the rotating? Ready? What it does? It said about okay. New set. Stream buffer. Split. We didn't do split. We don't do split. Oh. So actually it would be linear time. This is not good. We could just do the appendix, right? The time complexity is not right? Yeah, linear. Anyway, I think it should be linear. Cool. Why? Because this word, for each word, we loop through all the index. Yes, we use slice, but this will actually, each letter will be sliced for just for once. So this is linear time. And this will get all the words. And for each word, we check the first letter and do the slice. Okay, we use a slice, but all of them will be sliced for extra once. And we plus them and transform plans. And yeah, it should be linear time with constant space. Okay, so that's all for this one. Hope it helps. See you next time. Bye bye.